It's exercise 1. We have a function here. The graph of we have a function, and the diagram shows the graph of the derivative of the function. And exercise A, explain why the graph of f has a local minimum when x is equals to 5. We see that x is equals to 5. We see that the derivative, which is the graph we're looking at here, has a 0 point when x is equals to 5. So since the derivative has a 0 point, that means that the function has either a minimum point, maximum point, or a transfer point. And we see that the graph of derivative, goes from negative, it's negative here, and then it's positive. And when the derivative goes from negative to positive, we know that the function goes from decreasing to increasing. So this means that this is a minimum point. Exercise B is more difficult. Find a set of values of x for which the graph is concave down. Okay, and how can we see that? By looking at the graph of derivative. Remember that if the second derivative is concave down, was it? Concave down means that the graph looks like this. The graph of f should look like this. And then we know that the second derivative has to be negative. If the second derivative is negative, then the graph is concave down like this. But what about the derivative? And the thing is, if a function decreases, then its derivative is negative. If a function f is decreasing, then the derivative is negative. And this is the derivative of this. So when this is decreasing, then this is negative. And when is this graph decreasing? That's when x is between 2 and 4. So when x is between 2 and 4, then we see that f derivative is decreasing, which means that the second derivative is negative. And if the second derivative is negative, then the function is concave down. So the answer is that x has to be between 2 and 4.